Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In the last video, we have discussed about Doppler effect. In today's video, I will explain you what exactly Doppler effect is and how to derive Doppler effect equations. Doppler effect is all about apparent change in frequency of a wave. So what exactly it means? It simply means that the frequency produced by a source and frequency observed by a listener. These two are different. And why these two frequencies are different? Because there is a relative motion between observer and source. If there is no relative motion between source and observer, there will be no apparent change. It simply means that the frequency produced by source and frequency observed by listener, these two frequencies will be same if there is no relative motion. If you look at the first animation, you can simply see that the source is at rest and observer is also at rest. Simply, we can say there is no relative motion between these two. So the frequency produced and frequency observed, they are the same. If you look at the second animation, you can see that as the source is moving and when the source is approaching listener, frequency is increasing, and as the source is moving away from listener, frequency is decreasing. So in second animation, observe frequency and frequency produced by source, they are not same. So this is all about Doppler effect. First of all, let's try to understand what exactly time period is. Time period, simply we can define that the time passed between two consecutive crests. So what exactly it means, we can understand like this. Let's say we have source here and we have a listener that is at this point. So this one is our listener, and the source is producing waves, and let's say the first crest received by this listener is 1, and this source produce another pulse, and after a certain period of time the source will receive the second crest. Let's say this is our second crest, and the time passed between these two crests is simply called time period. Until now, I hope that you have clear understanding of Doppler effect. You understand that how frequency change when the source is approaching listener or when the source is moving away from listener. And you also understand what exactly time period is. Time period is simply the time passed between two consecutive crests, or we can simply say that it is the time observed between two crests by observer. So that is time period. Now we will use our understanding of these two concepts and we will derive Doppler equation when the source is moving away from listener. Let's try to understand what is happening when a source of sound is moving away from listener and listener is at rest. So let me explain to you this with very nice animation. So watch this carefully and try to observe what is happening. If you have observed this animation carefully, you must have seen that at the beginning, at time t is equal to 0, source was at this point and source was moving to the left with speed u sub s. When the source was at this point, source produced pulse 1 at time t is equal to 0, and this pulse continues moving to the right and reaches this listener after time t is equal to capital T. But in the same time, the source continues moving to the left and reaches this point. And in this time period, the distance traveled by the source, this is equal to u sub s t. Let's say this point is point A and this point is point B and this point is point C. And when the source reaches at point C after time t is equal to capital T, source produce an other pulse. Now what we need to find is that simply we need to find out after how long this second pulse will reach the listener at point P. So that time period simply we need to find. If we can find that time period, then we can find the observed frequency by listener. So let's try to find out observed time period by listener, or simply we can say observed time period is the time between two crests received by observer. So that time period simply, if we know the distance between two crests, and we also if we know what is the speed of the wave, means the VW, then simply we can find out time observed by observer. So let's say VW is equal to V, means this is the speed of wave. Now distance, let's say this distance, this is d2, simply I can say the distance traveled by the source in time period capital T, and the distance traveled by the pulse 1, let's say that distance is d1. So we can write down distance in terms of velocities now. So we can say this is v capital T plus that will be u sub s t divided by the speed of wave. So I will simply use v here. Now if we little bit rearrange this one, we can simplify this. As the t is common, we can just take this t out. We can say v plus u sub s divided by the speed of wave. Now this is in terms of time period, but what we need to find out, we simply need to find out observed frequency. As you can see here, this is what we need to find out. Now we need to understand the relationship between frequency and time period. So frequency is simply equal to 1 over time period. So we can take inverse on both sides and we can simply write down 1 over time period, and here we can simply say v over v plus u sub s. And also as the time period we also take inverse, so this is 1 over t. Now simply the first one is observed frequency, so we can say f naught is observed frequency, and we left with v over v divided by v plus u sub s, and here is the frequency of source. So 1 over t means the time period of wave. This is 1 over t is equal to f sub s. Now if we look at this one carefully, we can see that this denominator, this is greater than numerator. So we can simply say that in this case observed frequency has to be lower than the frequency of the source. So this is how we can find out observed frequency when the source is moving away from listener and listener is at rest. So here is our listener. So listener is at rest. So in this case, lower frequency. So frequency heard by listener will be lower than frequency produced by source. Let me also explain to you how you can find out the lambda observed. So lambda observed actually is the wavelength observed by observer, and that is equal to the distance between two crests observed by observer. So we can simply say lambda observed is equal to the wavelength of the wave produced by source plus the distance traveled by source. So lambda in this case, this is equal to v times capital T, and the d, the distance traveled by source, that is equal to u sub s t. We can simplify this one. We can take t common, so we can also write down like this, t common. So if time period is given to you and the speed of the source and the speed of the wave is given, so this is how you can calculate lambda observed by observer. But if the time period is not given, the frequency is given, we can also rearrange this one and we can write down this equation in terms of frequency as well. So in this case, time period will be equal to 1 over frequency, and we can replace time period with frequency. So our relationship will be like this. So this is v plus u sub s, and this will be divided by f, and this f is the frequency of source. So this is lambda observed. So this is how you can calculate.